Good morning, students. Today we are going to module 3, chapter 5 of the book Introduction to Data Mining, second edition by Tan, Steinbach, Karpatnai, Kumar, Vipin Kumar. Whatever the slides given by the author, the same slides I am using here. I thank the book authors for providing these slides. So, in this chapter or in this module, we are basically going to deal with association analysis, association mining rules, rule generation, then support count, confidence, then support count using hash tree or hash algorithm, then FP growth algorithm, and then evaluation of association root algorithms. So, coming to the first slide, so association rule mining, given a set of transaction, find rules that will predict the occurrence of an item based on the occurrence of the other items in the transaction. So, here if one customer visits a grocery store and buys one product, so associated rule mining is to predict which next product he will buy. So, here on the left hand side we have a market basket transaction with the transaction ID 1, 2, 3, 4 and 5. So, customer 1 has bought bread and milk, customer 2 has bought bread, diaper, beer and eggs, customer 3 has bought milk, diaper, beer, coke, customer 4 has brought bread, milk, diaper, beer, and customer 5 has brought bread, milk, diaper and coke. So, from this we are going to generate association rules as example of association rule. So, if you see from the market basket transaction, so whenever a customer has bought a diaper, he has bought beer, looking into the transaction 2 and 3, and whenever a customer has bought milk and bread, he has bought eggs and coke, and whenever a customer has bought beer and bread, he has bought milk. So, this is an association rule. So, that is nothing but whenever a customer buys a diaper, then there is a chances of that he buys a beer. Whenever a customer buys beer and bread, the chances that he will buy a milk. So, here implication means co-occurrence, it is not causality. Co-occurrence means there are chances. So, based on this, uh, the grocery store, whenever he keeps a product bread for the sale, so he need to take care that milk is also present in the uh, store so that customers can buy it. Okay, next coming to the definition of a frequent item set. What is a frequent item set? So, on the right hand side you see a table with the transaction ID 1, 2, 3, 4 and 5 with the items bread, milk, diaper, beer, coke and so on. So, if you see the transaction 1, 2, 4 and 5, in all the 4 transactions 1, 2, 4 and 5 bread is brought, that is it is a frequent item, it has brought 4 times, means 4 customers have brought them. Then if you see milk, customer 1, 4 and 5 have bought the milk. Diaper is been brought by 2, 3, 4 and 5, 4 customers have brought diaper. So, whereas beer is bought by the 3 customer and egg is only by second customer. So, here frequent items, bread is a frequent item, diaper is a frequent item, milk is a frequent item, beer is a frequent item, okay, coke is also a frequent item and egg is not a frequent item because it is brought only one. So, what is a frequent item set? So before going to the frequent item set, let us know what is an item set. A collection of one or more items is called as an item set. Example, so milk, bread and diaper is one item set. So if an item set is having k items, then we call it as an k item set. An item set that contains k items is called as k item set. Next is support count. Support count is nothing but frequency of occurrence of an item set. Frequency of occurrence of an item set. For looking at the right hand side, the table, the market basket transaction, milk, bread and diaper. Milk, bread and diaper is being bought by the fourth customer. Milk, bread and diaper is also being bought by the fifth customer, that is transaction ID 4 and 5. So here bread, milk and diaper has having a frequency of 2 times it is being repeated. So the frequency of milk, bread and diaper is 2. So the support count sigma is 2 for this item set milk, bread and diaper. So then what is support? Fraction of transaction that contain an item set. Fraction of a transaction that contain an item set. Example, support is represented by S, milk, bread, diaper. So milk, out of the 5 transactions, how many times milk, bread, diaper has occurred? 2 times. So 2 times it has occurred, total number of transactions is 5, 2 by 5. So that is a support. Frequent item set, an item set whose support is greater than or equal to min sup threshold is called as a frequent item set. So what is that min sup? Min sup is minimum support. For every transaction, uh, we set up a minimum amount of support value. So if item is having a threshold, if an item is having support more than that threshold, then only that can be considered as a frequent item set, otherwise it is not. Okay. Association rule. So what is an association rule? Definition: an implication expression of the form x belongs to y, where x and y are the item sets. So that is, if I buy an X item, then there is a chances that Y is also being bought. For example, if I buy milk and diaper, then there is a chances that B also is being bought. So if I want to evaluate association rules, so rule evaluation matrix I need to apply. So if I want to apply rule evaluation matrix, so 2 things we need to consider. One is support count and second one is confidence. Support, what is a support? Fraction of transaction that contain both x and y. Support is what? Fraction of transaction, a transaction that contains both x and y. So means in the example we have milk, diaper and beer. So I need to find a transaction, means if I buy milk and diaper, then also beer should be present. Then confidence measures how often item y appears in the transaction that contain x. So means how many times beer appear in a transaction which contains milk and diaper? That is nothing but the confidence. So support is nothing but a fraction of transaction that contains both x and y. For example, transaction number 3 where milk, diaper is present and beer is also present, that represents a support. And confidence, so confidence if you measure, so if you take beer, beer is present in a transaction number 3 and 2. In transaction 3, milk and diaper is present. So means if x is milk and diaper, y is beer. So we need to find out a transaction where beer is present when milk and diaper is also present. So example, so if you see milk and diaper, so if you see milk and diaper support count S is equal to confidence. S is equal to what? It is a support count sigma milk diaper beer divided by T. T is the total number of transactions. So T is what? T is the total number of transactions. So milk diaper and beer has happened in 2 transactions and total number of transactions is 5. 2 by 5 is 0.4. So 0.4 is support count, or nothing but 40% is the support count. If you want to calculate uh, confidence, milk diaper and beer, so divided by milk and diaper, where milk and diaper is X, milk diaper and beer is Y. So 2 by 3 is equal to 0.67. So that is confidence. Okay, so this is how we find out the support. We find out uh, S is what? The support count, and C is nothing but what we call it as a confidence. So milk diaper B is your support count divided by support count of milk, that 2 by 3 is equal to 0.67. So that is how we find out the association rule. So association rule mining task. So given a set of transaction T, the goal of the association rule mining is to find all rules having, so your support should be greater than minimum support, and confidence should be more than greater than or equal to minimum confidence threshold. So what is this minimum support? Consider, for example, you have 10 transactions. In that 10 transactions, so I will define as minimum support is equal to 3 or minimum confidence equal to 3. Means in 10 transactions, if I take milk as an example, so milk should at least 3 customers should buy, out of 10 customers, 3 customers at least they should buy a milk if they want to satisfy the condition. Okay, so now confidence, that is also there. So that there also a minimum amount of customers should buy a milk product, so then only it will satisfy the condition of this support as well as confidence. Next, coming to the brute force approach. So here what we are doing, so list all possible association rules, compute the support and confidence for each rule, prune the rules that fail minimum support count and minimum confidence threshold. So here what we are doing, so if out of 10 transaction, let us assume out of 10 transaction, if egg is bought only in only one transaction, then its support count is 1. If the support count I have set is 30% and your egg is only 10%, such transactions have to be removed. So that is pruning is nothing but cutting down. So computationally prohibitive. Why this is computationally prohibitive? Because it need to generate. So I need to generate every possible set of transaction. I need to check and I need to calculate their confidence and support. For that reason, it is computationally prohibitive. What is the computational complexity involved in the brute force approach? Is given D unique items. So if you take uh, D is a unique items, the total number of item sets is 2 raised to D. So 2 raised to D is the total number of item sets that can happen. And total number of possible transaction rules is according to R. So summation k equal to 1 to k equal to 1 to D minus 1 d by factorial of k, factorial of d by factorial of k into summation j equal to 1 to d minus k by j. So that is 3 raised to d minus 2 raised to d plus 1 by plus 1. If d is equal to 6, if I take 6 unique item sets, then it will be around 602 rules. So that is what the complexity of a brute force approach. For that reasons, we cannot go for brute force approach. So mining association rules. So again, take market basket transaction with the transaction ID 1, 2, 3, 4 and 5, and with transaction 1 bread milk, transaction 2 bread diaper beer and eggs, transaction 3 milk diaper beer and coke, transaction 4 beer bread milk diaper and beer, transaction 5 bread milk diaper and coke. So examples of rule. So if you take milk diaper, beer. How many times a milk diaper is being brought? So we in the previous example here we have already calculated. So milk diaper belongs to beer. So where S is 0.4 and C is 0.67. That is already we have calculated. How you calculated, you know. So milk diaper B divided by total number of transactions 5, that will give S is equal to 0.4. So if you divide milk diaper beer by milk diaper, you will get 0.67. Similarly, if you follow the method for milk beer with a diaper, support is 0.4, confidence is 1. Diaper beer milk, S is equal to 0.4, C is equal to 0.67. Similarly, and so on. So what observations we find from these association mining rules? So all the above rules are binary partitions of the same item set. So we have binary partitions means, so if you observe, in every transaction we have either milk or a diaper or a beer. Rules originating from the same item set have identical support but can have different confidence. So if you see, so in all the 5 transactions, in the all the 6 transactions we are taking the examples for rules, for everywhere support is 0.4 whereas confidence is 0.67, or confidence is 1 or confidence is 0.5. So it means that support may be identical but a confidence may be different. Thus we may decouple the support and confidence requirement. So we cannot set the support requirement same as confidence requirement. We can have different confidence requirement, or we can have a different support requirement. So mining association rules, there are 2 steps or 2 approaches to go for this. So first one is frequent item set generation, and second one is rule generation. So in frequent item set generation, what we are doing, we are generating all the items whose support count is, or whose support is greater than minimum support count or minimum threshold. So if I set minimum threshold equal to 30%, means at least out of 10 transactions, in 3 transactions a particular item should appear. Rule generation, generate high confidence rules from each frequent item set, where each rule is a binary partition of a frequent item set. So in first approach we are applying the concept of mean sub, and the second method we are applying the concept of confidence. So still frequent item set generation, still it is computationally expensive because here we apply 2 raised to d. So if d is equal to 6, so there are around 606 different rules we need to go for it. So here is an example of frequent item set generations. So if you take given d item sets, so what are the possible item set? 2 raised to d possible item sets are there. Okay, so now here take an item set A, B, C, D, E. So first one is A combining with B, C, D, E. So you'll get AB, AC, AD, AE, and A combined with B. You'll get AB, AC, AD, and AE. B combined with C, BC, BD, BE. We need to leave A. C combined with DE, because why we are not taking B combined with A? Because already B and A are present, so we are not taking it. So next C with A is already present, C with B is already present, so we need to go for C with D, CD and CE, then finally DE. So we are not going with DC, DB or DA because already they are present. Then follow the same method, combining these things. ABAC common is A, so we need to go for ABC. So if we combine AB with AD, common is ABD. So now if we combine AB with AE, so common is ABE. Okay, so next AC I need to take. AC combined with CD, you will get ACD. So following the same method, we will find all these things. Then ABCD, ABCE, ABDE, ACDE, BCDE, and finally ABCDE, which is having all the 5 item sets. So first at initially you have null, next at we have 5 item sets A, B, C, D, E, that is level 1. Level 2 is having 2 items, level 1 is having only 1 item, whereas level 2 is having 2 item sets with the combinations of A, B, A, C, A, D. Third level is having 3 items, fourth level is having 4 items, and fifth level is having 5 items. So this is frequent item set generation. So frequent item sets are AB, AC, AD, AE, BC, BD, BE, CD, CE and D. So what are the possible combinations I can get? 2 raised to 5. Here 5 item sets are taken. So A, B, C, D, E, then A, B, C, A, B, D, A, C, D, B, C, D. These are the 4 possible combinations, and finally is A, B, C, D, E. Now if you take brute force approach. So in this example, each item set in the lattice is a candidate frequent item set. So each item set in the lattice is a candidate item set. So here this transaction I did 1, bread milk is one candidate item set, frequent item set, bread, diaper, milk, beer, eggs is a frequent item set. So similarly count the support for each candidate by scanning the database. So here n is the number of transactions and w is the number of transactions which are having the candidate item sets. So match each transaction against every candidate. So now if I go on uh, checking each transaction with every other transaction, then how many frequent item sets I am going to generate. So in the brute force method already I told m is equal to 2 raised to d. So the complexity is O, complexity O is equal to n into m into w. So that is expensive since m is equal to 2 raised to d. Now if I want to reduce the frequent item set generation, what I have to do? So what are the strategies that I need to follow so that frequent item set generation can be reduced? So first one is reduce the number of candidates m. So complete the search m is equal to 2. So now what you can do is reduce the number of candidates m. So by using by reducing the number of candidates m, so we can reduce the number of comparisons or number of frequent item set generations can be reduced, or use pruning techniques to reduce m. Means we need to reduce or we need to eliminate the items which does not have the frequent item sets. Next is reduce the number of transactions n. So instead of having a huge number of transactions, take less number of transactions. So reduce the size of n as the size of the item set increases. So that is used in a vertical based mining algorithm. Or another method is reduce the number of comparisons. So that is n and m. Use efficient data structure to store the candidates or transactions. No need to match every candidate against every transactions. So there are 3 methods or 3 strategies using which we can reduce the number of comparisons in frequent item set generation. First one is reduce the number of candidates, or reduce the number of transactions, or reduce the number of comparisons. So now how we can reduce? How we can reduce the number of candidates? So here one important principle is taken into consideration, so that is called as an a priori principle. So if an item set is frequent, then all of its subsets must also be frequent. So now what does it mean? If an item set is frequent, then all of its subsets must also be frequent. For example, if bread, milk, diaper and beer is a frequent item set, then bread, milk, one combination should also be a frequent, diaper, milk should also be a frequent item set, diaper, beer is also should be a frequent item set. That's what it says. So if an item set is frequent, if any one item set which is having 4 or 5 items, if it is a frequent, then all of its subsets must also be frequent. So what an a priori principle says? So a priori principle holds due to the following property of the support measure for all x and y. So x belongs to y, that is support count of x should be greater than or equal to support of y, means x is a frequent item set and y is a subset of x. So S of x greater than or equal to S of y. Support of an item set never exceeds the support of its subsets. So here what it says, support of an item set never exceeds the supports of its subset. Okay, so support of an item set never exceeds the support of its item set subsets. This is known as anti-monotone property of the support. So if an item set never exceeds, if S of x never exceeds the support of its subsets S of y, this property is called as anti-monotone property of support. Okay. Now let us see an example. So here let us take an example of to illustrate the principle of a prior principle. So null, initially a node, a root node, A, B, C, D are the 5 item sets, are the 5 items. A may be milk, B may be diaper, C may be beer, D may be coke, and E may be eggs. So now in the previous example we have seen A combined with B, AB, AC, AD, AE, BC, then BC, BD, B, then CD, C, then D. Similarly, uh, combining AB with AC, you will get ABC, ABD, ABE, ACD, AC, and so on. Then ABCD, ABCE, ABDE, ABACD, BCD, and ABCDE. Now, for example, if any one of the item set is infrequent, consider for example AB. So here AB, let us assume AB is found to be an infrequent item set. Consider AB is found to be an infrequent item set. Then what happens? Then all of its supersets are also will also be the infrequent, because if any item A and B which is found to be infrequent, then its next supersets combinations are also infrequent. So you can see here, if AB is infrequent, then ABC is also frequent because it contains AB. ABD is also infrequent because it contains AB. ABE is also infrequent because it contains AB. ABCD is also infrequent AB because it is contains AB. ABC is also infrequent because AB is part of it. ABD is also infrequent because AB is also a part of it. ABCD is also infrequent because AB is also a part of it. So that is AB, if AB is infrequent. So similarly, if AC is infrequent, then ACD is infrequent, ACV will be infrequent, ACD is infrequent. Okay. So now what I can do with this? So when AB is found infrequent, so when any one of the items set, so here there are 2 items in this set, if this is found to be infrequent, then all these can be eliminated from the lattice structure, because these are no longer frequent item sets and these are no more required for our analysis. They are no more required for the data mining analysis techniques. So these will be pruned. Pruned means we'll cut off them from the lattice structure. So illustrating the a priori principle. So again the same market basket transaction with TID is equal to 1 to 5, and with the bread, milk and diaper, eggs, and so on. So now item set 1, let us take minimum item set is equal to 1. So now here minimum support is equal to 3. What is this minimum support equal to 3? So in 5 transaction at least an item should appear for the 3 times. Item should appear 3 times. So now if in this example if every subset is considered, then 6cc1 plus 6cc2 plus 6cc3, so that will be 6 plus 15 plus 20 is equal to 41. Now if we apply with support based pruning, it will be just 6 plus 6 plus 6 is equal to 16. How it is? So now what we have taken? We have taken minimum support is equal to 3 here. So now count in every transaction how many times bread has occurred. Bread has occurred in 1, 2, 3 and 4. So bread is 4. So its support is 4. Coke in transaction ID 5 and transaction ID 3. So Coke is occurred only 2 times. Milk has occurred 4 times. Milk has occurred in 1, 2, 3 and 4. So support count for milk is 4. Beer is 3 because 1, 2, 3 and 4 contains beer. Diaper is having 1, 2, 3 and 4, and eggs is only once in transaction ID 2. So now what? Now bread is 4, Coke is 2, milk is 4, beer is 3, diaper is 4, egg is 3. So now what I can eliminate from this? So frequent item set Coke is not a frequent item set because it is less than the minimum support value of 3, and egg is also will be eliminated or it will be pruned because its support count is less than 3. So that's what Coke is having 2, egg is having 1. So these two items are removed from the frequent item set list. So now frequent item sets are only bread, milk, beer and diaper. Why I am considering this is because here we have taken minimum support is equal to 3. Okay. So now item set 1. So now what are the possible combinations now? Item set 1. So now combine each and everything. Okay, so Coke is removed, egg is removed, bread combined with milk. First is bread milk, bread combined with beer, bread and beer, bread combined with diaper, bread and diaper. Next you take beer combined with milk, beer milk, then diaper combined with milk, then beer combined with the diaper. Okay, so this is items, one item sets. Okay, minimum support is equal to 3 again here. So now here see again, bread and milk, how many times? 1. Okay, so beer bread and beer milk as having support count only 2. Beer and bread has occurred in only 2 transactions. Bread has occurred in 1, 2 and so on. So bread milk is 3, beer bread is 2, bread diaper is 3, beer milk is 2, bread diaper milk is 3, beer diaper is 3. So now if you take again beer bread and beer milk are not satisfying this minimum support count, so beer bread and beer milk will be eliminated from the count. Now next item set, this is pay 2 item set, no need to generate candidate involving Coke and eggs because I am not interested because the minimum support value is less than 3. Triplet, now triplet combined beer diaper milk count is 2, beer diaper bread beer bread diaper support count is 2, beer bread diaper milk support count is 1, beer bread and milk. So here beer bread milk 1, this is 1. So this is the final triplet 3 item sets which are found to be frequent. Now coming to the a priori algorithm, f of k is a frequent item set, f of k is frequent item set and L of k is candidate item set, k item sets. Algorithm, what algorithm? A priori principle says that k is equal to 1, then generate f1 frequent first item set, then generate candidate generation repeats until f of k is empty. Candidate generation, generate L of k plus 1 from f of k. Candidate pruning, remove the candidates which are not satisfying the minimum support count. So support count and count the support of each candidate by scanning the database. Candidate elimination, so if any one of the candidate does not satisfy the principle of minimum support, those candidates will be eliminated from the uh, frequent item set list. So this is again a brute force method for generating 3 item sets, candidate 3 item sets. So here again we can see uh, beer, bread, cola, diaper, milk, and eggs. Now combine everything with everyone. Now take first beer, combine with beer, bread, and cola, then beer, bread, diaper, beer, bread, milk, beer, bread, eggs. Then start with then beer, cola, diapers, beer, cola, milk, beer, cola, eggs, and so on. Similarly, then start with bread, bread, cola, diaper, bread, cola, milk, bread, cola, eggs, bread. Now start with bread, diaper, bread, diaper, eggs, bread, milk. So combine each and everything with first starting with first take two items beer and bread, combine with cola, next take combine with diaper, combine with milk, and combine with eggs. Then leave the bread, take combination of beer and cola combined with diaper, milk, and so on. So these all these things. So when you apply a brute force method to all of these, so candidate pruning final item set. So the frequent item sets that we found is only bread, diaper, and milk. Whose support count is more than 3. Frequent item set generation second list. So B diaper, bread milk, and diaper milk. These are having software pruning. So these are the frequent item sets whose support count is more than 3. Okay, so now take candidate generation. So another method how we can generate candidates. So merge f of k minus 1 and f of 1 item sets. Frequent item set 2. So beer diaper, bread milk, diaper milk, beer, bread, diaper, and milk. Combine frequent 2 item sets with frequent 9 item sets, then you will have candidate generation, beer, diaper, and bread. So first take beer diaper combined with beer is already present, will not go for that. We'll take bread. Beer diaper will not combine, we'll take only milk. So beer, diaper, and milk. So then start with bread diaper and milk, because beer is already present with bread. So then bread milk with beer. So this is a candidate generation. Then again candidate pruning. So now bread, after applying the candidate pruning, so now what you can get, bread diaper milk is only a frequent item set that can be considered. So generating and pruning candidate k item sets by merging frequent k minus 1 item sets with frequent item sets. Note that some of the candidates are unnecessary because their subsets are infrequent. So why we have eliminated so many combinations? So why uh, beer diaper bread is being eliminated, beer diaper milk is eliminated? So why only bread, milk, and diaper is considered is only because the support count is more than 3. Then only we are taking into it as a frequent item set and we are using it for association analysis, but rest of the things are not considered. Okay, now again the same method. So now we are, so here in the previous example, 2 item sets combined with 1 item, we get candidate generation, and we did candidate pruning, and we eliminated the candidates which doesn't satisfy the principle of, which doesn't satisfy the minimum support count. So now candidate generation, now f of k minus 1 with f of k minus 1. Now 2 item sets, f of k is first item set, k minus 1 is two item sets. B diapers is a 2, B bread diaper is 2, bread milk is 2, bread milk is 2, B diaper is 2, bread diaper is 2, bread milk is 2. So this is all frequent item 2 item set. This is also 2 item sets. Now if I combine 2 item sets, so now what, again candidate generation, if you go again you will find bread, diaper, and milk is only the 3 item set, 3 item sets, 3 candidate 3 item sets, because only bread, diaper, and milk satisfy the minimum support count of 3, because they occur in more than 3 transactions out of 5 transactions. So this is again a candidate generation where bread, milk, and diaper is only candidate pruning. After applying candidate pruning, we get only bread, milk, and diaper. So now candidate generation, fk minus 1 into fk minus 1 method. So now how merge two frequent k minus 1 item sets if their first k minus 2 item sets are identical. Now, what we are doing here? So now here merge two frequent k minus 1 item sets if their first k minus 2 item sets are identical. So F3 left as example ABC, ABD, ABE, ACD, BCD, BDE, CDE. So now take first ABC and ABD. Take first these two ABC and ABD. So AB and AB is present, merge that. So next we will be having AB on CD. So ABC, ABE, merge AB. So ABC, ABD, ABE, take only AB, DE. Do not merge ABD and ACD because they share only prefix of length 1. So here we need to share prefix with length 2, means here AB is common in this first, second, third. Okay, now AC is not common, AC is only once, BC is also only once, BD is also only once, CD is also only once. So merge we cannot merge A and A because its length is also 1. So we need to take length 2, then merge. We cannot merge because we don't have AC repeated over here, BC repeated over here, or BD repeated over here, or CD repeated over here. Okay, so now F3 is ABC, ABD, ABE. In the previous example, with a set of 3 frequent item set L4, length 4, ABCD, ABC, and ABD. What we got here? These are the ABCD, ABC, and ABD. So is a set of candidates with 4 items set generated from the previous slides. So after applying the candidate pruning, so what we are getting, these things. So after getting prune ABC because AC and BC are infrequent. So in the previous example, which in the previous example, so candidate pruning, prune ABC. So out of ABCD, ABC and ABD, so he is asking me to prune this ABC. Why? Because AC is also infrequent and BC is also infrequent. So if AC is also infrequent, BC is also frequent, wherever AC is present or BC is present, then that has to be frequent. So ABC is also pruned, ACE and AD is also infrequent, so ACD is also eliminated. So final candidate pruning after Fk minus 1 into Fk minus 1 into Fk minus 1 method. So after candidate pruning we'll get only L4 ABCDE because ABCDE all are frequent. ABC is also frequent, ABD is also frequent, BCD. So all these things are frequent. So after candidate pruning we'll get only ABCDE. Okay, so this is already we have done with. Okay, that's all for the day. In the next class, we'll go for support count using hash tree. Thank you, one and all.